Okay, the table at the top has both directions. So it has the multiplying of these that we did in the last unit. And here, we're going to take it back to the original factored form. Looking for the GCF on each of these. We will be looking at several different things with factoring. Today is just greatest common factor. Okay? So along the lines of what we were doing today on the activity, 24 and 48 can both be divided by 24. That would be the largest one. So I'm just going to go with, say, 12, just to show what we're looking at. A lot may not pick the largest thing. So if I were just to divide both of these by 12, make myself some room. Do they have any variables that are the same? No, one has an X, one has a Y, so I can't do anything there. So then I divide both 24 and 48 by 12. 24 divided by 12 leaves us with 2x plus 48y divided by 12 leaves us with 4y. This is what happens if you do not factor out the greatest common factor, is I can still divide 2 and 4 by 2. So if I can divide both of those by 2, 2 divided by 2 is 1x. 4y divided by 2 is 2y. So eventually you can get to the greatest common factor, even if you don't pull the largest factor out first. It's still going to come to that. What about number 2? 9 and 3 can both be divided by 3. And how many x's do they have in common? 1, correct. So the question is, I can take 2x's from the 9x squared, but can I take 2x's from the 3x? No, so then it doesn't have an f, so it's just the 1. So looking at that division, I'm dividing each of these by 3x. That's what's happening. So 9x squared over 3x becomes 3x minus 3x divided by 3x becomes 1. When we're working with these, again, 9 divided by 3 is 3. X squared over x, remember we're subtracting our exponents. So that's the property we're going to be working with today, is subtracting those exponents. All right, for number 3, I have 30, 1, and 6. So there's nothing I can work with there. Variables, do they all have an M? Okay, so that's out. What about P? Okay, I have 2 here on the first one, 1 on the second, and 1 on the third. So how many can I grab? 1. So if I divide each of these by P, then I'm left with 30 M and 1P I'm left with m squared on the second one, because I've divided the p out, and I'm left with 6 minus 6 on the last. Looking at that in the parentheses, there should not be anything common at that point. All right. Any questions on these three? Where we got the numbers, where we got what's left in the parentheses? All right, so let's take a look at the next row. 4, so the way I look at these, I look at the number first. So I'm looking at 4, 6, and 8. They can all be divided by? Can 6 be divided by 4? That's okay. And that's the hardest part when you have more than 2 numbers. It has to be able to work on all of them. So they all can be divided by 2. Do they all have an M? Do they all have P? Okay, so 2 is it. So I'm going to divide each of these by 2. Four m divided by 2 should leave me with 2m plus 6p divided by 2 should leave me with 3p minus 8mp divided by 2 should leave me with 4mp. Looking at this, I cannot divide 2, 3, and 4 by the same thing except 1. So we know we've got enough out. All right, number 5. Can I divide 4, 28, and 7 by the same thing? 1 is it, so we're not going to worry about that. Do they all have an A?
Yes.
Okay. Do they all have a B? Okay. So that means I'm going to divide each of these by AB. See what you can come up with for what's left of that. So when I am number 5, so the first one, I'm left with 4A. When 28AB squared, I should have 28B. And when I take a look at the last one, I'm just left with plus 7. But when you're looking at these, so we know the numbers 4, 28, and 7 can have a common factor except for 1. Then look to see if you pull enough of the variable out. There shouldn't be anything common there either. All right, see what you can do with number 6. All right, I'm going to take a look at this one. First off, 14, 42, and 49. Well, it's not going to be 2, because 49 can't be divided by 2, but what can they all be divided by? 7. How about T? How many T's? 3. So dividing all these by 7t to the third. So then that makes 14 divided by 7 is 2. T to the third over t to the third, the variable's gone. Because that's t to the 0, which is 1. The next one, 42 divided by 7 is 6. T to the 5th divided by t to the 3rd leaves you with t squared. 49 divided by 7 is 7. T to the 4th divided by t to the 3rd is t to the 1. How do we do? All right, see what you can do with this row. All right, so number 7. 4, 12, and 16 can all be divided by 4. How many x's? 1. Correct. So I'm going to divide each of these by 4x. And 4x divided by 4x is 1. 12x squared divided by 4x leaves you with 3x. 16x cubed divided by 4x leaves you with 4x squared. Number 8. 6, 12, and 8 can all be divided by 2. Any common variables? No. So that's just it. All of them are divided by 2. So 6y divided by 2 is 3y. 12x divided by 2 is 6x. 8z divided by 2 is 4z. Number 9. 45 and 15 can both be divided by 15. How many r's? 2. Correct. So 15 r squared on each. So 45r cubed divided by 15r squared is 1r. No, just kidding. 3r. Just kidding. 15r squared divided by 15r squared, 1. So that's the reason why I showed that those are being divided like that, because the common thing I see students do is just write that as 15r squared times 3r, and that's it. You haven't subtracted the factor out, you are dividing it out. Okay? All right, factoring by grouping. Something that we will need when we work with the trinomials, the 3-termed ones when we come back. And it also uses. So grouping means exactly that. We are going to group certain things together. You have to have 4 or more terms. In other words, you have to have 4 terms, 6 terms. You have to be able to group it into usually pairs. So I look at it like this. Treat this as 2 separate problems. So I've got x squared plus 2x. That's the only thing I'm looking at right now. What can I divide both of those by? 1x. X squared divided by x is 1x. 2x divided by x is 2. Now I look at this next part. X plus 2. The only thing I can divide that by is 1. A positive 1. Which means it's still just x plus 2. And this is what happens. I have a matching x plus 2 factor. So I have x plus 2 in common. And I have x plus 1 as my other. Again, something we're just introducing here. We will work a lot more with this over the next 2 lessons after spring break. So on 11, just looking at 12a squared and 3a. What can I divide both of those by? 3. 12a squared divided by 3a is 4a. 3a divided by 3a is 1. All right. Sometimes you have to factor out a negative. And in this case, first of all, I'm just going to look 8a and 2, I can divide them both by 2. But I need to divide them by a negative 2. And you'll see this in a minute. Negative 8a divided by negative 2 is a positive 4a. Negative 2 divided by a negative 2 is a positive 1. So this is why, because I needed a positive 4a plus 1. So my common 4a plus 1, and then 3a minus 2. See if you can do this last one. All right. So number 12, both of those can be divided by 4m, which leaves me with 4m squared divided by 4m is m. 4mp divided by 4m is p. The next group, both of those can be divided by 3p. And 3mp divided by 3p is m. 3p squared divided by 3p is p. So once again, I have m plus p as a match. So m plus p, and then 4m plus 3p as the other piece.
What is this?
Okay. All right. So the last piece is as you're factoring, solving. So zero product property. So if you have either factor set equal to 0, then you set each factor equal to 0 to see what makes it. So in other words, if we go back and look at something like number 7, that has the possibility of having 3 answers because it has x cubed. So if we look at 13 and 14, those are already factored. We know that because we see clearly the factors and multiplication. So step 1 and 2 are taken care of. We're on step 3. Set each factor equal to 0. And then we solve. Well, this one's already done. So the second one, I just need to subtract 3 from both sides. So x equals a negative 3. So this will equal 0 if I either put 0 in for x or negative 3 in for x. Because negative 3 plus 3 is 0 right here. And 0 will make that. So your solutions, you will likely end up with 2 answers on these things as you're working through the problems. So number 14 is also factored already. So I just set each factor equal to 0. On the first one, subtract 8. Then divide by 4. On the second one, add 3. So -2 or 3 are solutions for this.
Factor five.
Yeah, so you'll set up either 1 or 2 step equations as you're going through this. So if we look at the next two, those we need to factor. First of all, the equation has to equal 0. So on 16, I need to subtract the 25t. So I have 5t squared minus 25t. So first of all, before we do anything, factor both of those. Ignore that it equals 0. Just find the GCF, factor it, just like we did in the first part of the notes. On 15, I can divide both of those by 5. And what else? Variable-wise. P. Okay, so looking at that, 5p divided by 5p is 1 minus 15p squared divided by 5p is 3p. Set each factor equal to 0. 5p is one of them. One minus 3p is the other. On the first one, divide both sides by 5. P equals 0. On the second one, subtract the 1. Divide both sides by -3. P is a positive 1/3. So 0 and 1/3. On 16, I can divide 5 and 25 by 5 and by t. So 5t squared divided by 5t is 1t. 25t divided by 5t is 5. So there's your two factors. Set each factor equal to 0. 5t being one of them, and t minus 5 is the other. Divide both sides by 5. T equals 0 on the first one. Add 5 to both sides. T equals 5. Alright,